Good morning. It's a pleasure to be here. TerreformONE is a nonprofit design group in Brooklyn, New York, where we work on ecological design of future cities. Since today's topic is about standing on shoulders of giants, these are the giants that we need to fight. So, when we think about the future, there are three possible scenarios. End of the world, we leave that to Hollywood. But where our work is, it's between technofix, the idea that it will be a silver bullet of technology that will solve all the problems, in ecotopia, the idea that we need to live with nature and learn from nature. And here is our proposal for a future city called Ecotopia on the cover of Popular Science, showing tall bioclimatic building interconnected with bridges, canyonated transportation separating fast from slow traffic and pedestrians, and finally going in the air, moving with blimp buses and jetpacks. Discovered, however, this idea was not new. More than 100 years ago, Harry Pettit drew a very similar image of New York, interconnected tall buildings, canyonated transportation, in this case separating horse traffic from cars, and finally going in the air, dirigibles with passengers connecting to vertical cores. In order to achieve this goal of these ecological future cities, we decided to start a new profession to regenerate, pioneer, and sustain the future of urban Rome. These multidisciplinary advocates are called Urbaneer. They possess versatile skills and knowledge that bridge previously disparate occupations. Imagine if Jane Jacobs and Robert Moses were married. Very unlikely match, since they were arch enemies, but they have been worse marriages. So if these two had a child, that would be somebody like Frederick Law Olmsted, that will possess the community and sensibility of Jane Jacobs together with the magnitude of achievement of Robert Moses. Another excellent example of an urbaneer is Paolo Soleri. He passed away this week, so I wanted to pay respect to him. He was this visionary who invented the idea of arcology, the combination between architecture and ecology, and he spent 6 decades building his idea into the city of Arcosanti, which is built by the community and hopefully will continue to develop. So this is a very complicated chart, but it's the idea that we need these multidisciplinary advocates that will create the future cities. And we started school right in Brooklyn, where we teach that very notion. One lab has been existing for 5 years. Each summer, about 40 researchers gather from around the world when they experiment with principles of synthetic biology, parametric design, learning how to grow building blocks out of mushrooms, bleach trees into structural living walls, and learn the principles of phytoremediation using plants to filter water. We moved last month to the Brooklyn Navy Yard. This is 300 acres of industrial park owned by the city of New York right on East River. We're creating in this stunning old shipbuilding factory that once big turbines were built, this new center called New Lab. It's a collaborative design and fabrication center that will house under one roof several academic institutions, including Columbia University, Rensselaer Polytech, are starting new programs there together with us, a collective of innovators and small and medium-sized companies that are going to move there, experiment together, use the principles of digital fabrication and additive manufacturing. This is a private project is supported by a $46 million grant given to us by Mayor Bloomberg and Governor Cuomo and Speaker Quinn, possibly our future mayor. So this will open doors by the end of 2014, and at the same time, we are taking one lab globally. Next year, we'll be starting schools in Berlin, Barcelona, and Prague, and from there, we hope to go to Asia and Africa, South America. So, Urbaneering Brooklyn, imagining the city of Brooklyn 100 years from now. We start with a simple premise. We want the city to be self-sufficient within its political boundary. What we mean by that is that we can produce all food, water, energy that we need to sustain the population. The only thing that goes in and out is culture. So we always start with research where we are today. Currently, this is downtown Brooklyn, 0% of recycled water, 6% of renewable energy, which is really good, but we can do much better. And we went all the way to the beginning, when the city was founded. At that time, 93% of the land was used for what we call productive green space. This is space that produces food, produces energy, and it's also used to, in a form of wetlands, purifies water. Where we are today, 0% of productive green space. In order to achieve self-sufficiency, we have to go back and recreate that productive space, but using current and future technology. And to do that, we are proposing this method of reversing the figure ground. Take down the dilapidated building, exchange them with productive space, and design these very dense arteries that will combine living space, working space, and vertical farms together with soft transportation to create self-sufficiency. And this is the plan of the future of Brooklyn. We've taken out the BQE that was built by Robert Moses, and we are replacing it by a canal that will serve to also to deal with rising sea currents and other environmental challenges that are coming in the future. It's the model that travels around the world to exhibit this very notion of self-sufficiency. And this is a rendering of a future park where recreation will be combined with algae farms to produce energy. This is the new city center where the new tower is the water tower and the filtration system, where infrastructure comes in the foreground and becomes the new organizing principle of the future city. And then we continue now the research looking at the shore of Brooklyn, how to protect it from storm surges and the rising levels. This is the current project that we are working on using retired US naval ships, or so-called ghost fleets. We can cut them in pieces, submerge these sections to create gabion walls that can retain water and also provide a place for new estuarian habitat. And finally, this idea of soft transportation. These are the so-called blimp bumper buses. They move guided by funicular wire. You can jump on and off, and they have the ability to cross the water as well. And then this is all these ideas combined together into this soft transportation where everything possesses a modicum of intelligence and can communicate to each other, so giving always advantage to pedestrians, to people on bicycles. If a little girl drops her ball, the street will rearrange itself so she's never hurt. And then this is the idea of a soft car. It's actually soft, made out of air pillows. And these are the so-called Hawkins Lamb cars. So they're designed to bump into each other and kind of get scuffed like shoes. And if this car hits you, it won't hurt you. It will just tickle you. Rapid Refuse is a project about using waste as resource. We fell in love with this most affable robot called Wally, who builds these ziggurats out of waste. Today, New York City produces 36,000 tons of waste per day. We have no place to put it. We sell it to other states. It goes as far as Ohio and South Carolina. This is a model illustrating 1 hour of waste piled around the Statue of Liberty for scale. What we propose is to use off-the-shelf equipment, redesign the jaws, and compact it, separating metal, plastic, organic waste into these building blocks that can be incorporated into the construction process. So 36,000 tons of waste can become a 54-story tower every 24 hours. So in the future, we can live in a world that is waste-free, and we move to positive waste, that it's always used as a resource. Combine this technology of using waste as construction material with the research that we are doing in collaboration with synthetic biologists using mycelium, that's the root structure of mushroom, to grow a biopolymer that possesses really good characteristics. Combined together, we can grow a brick that has basically it's similar to a regular brick, has the same properties, but it's virtually free. Using a hydraulic press and growing mycelium, starting with a cellulose-based substrate, we can use any agricultural byproduct, cotton husk, buckwheat husk, and in 8 days we end up with this very dense polymer that we can grow in our laboratory. This is the structure. And then we're taking that now and proposing a completely new method of manufacturing where we can grow a seed called genetic generation seed, or Gen2 seeds. Again, this is a collaborative effort with synthetic biologists, and here we're using the mycelium as the body, and then growing a skin that is similar to leather, but we're using bacteria called Acetobacter psyllium. This is the same bacteria that is in a health drink kombucha. And this is our design for this biochair that is inspired by the human tailbone. And then these are some of the kind of the early research. This is the design, and this is the seed that we grew in our laboratory. So this started just by a few microorganisms in a petri dish, and in 8 days we have a seed. And when you are done using it, it doesn't end up in a pile of waste, but you can bury it in your backyard where it will feed other microorganisms. And this is little Mia Joachim. It's my business partner's daughter. She's turning 4 today. It's her birthday. And we hope when she grows up, she'll be living in one of these ecological cities that we are designing. Thank you.